Okay, so we're going to look at writing some molecular and balanced net ionic equations for double displacement reactions. So we look at problem number 3 here. Let's go through our steps. So first we're going to, let's write down our reactants. So we've got calcium acetate. Calcium has a +2 charge. Acetate is C2H3O2. That's one of those ones you should know. Has a -1 charge. So we need to have 2 acetates for every 1 calcium. Okay, and that's AQ because they tell us it's a solution. Potassium phosphate. Potassium has a +1 charge. Phosphate has a -3 charge. So it's going to be K3PO4. And they also tell us that that is a solution. So I'm going to write AQ. And I'm going to figure out my product. So I'm going to use my double displacement pattern to determine my new pairs. So K and Ca are going to switch places. So K is going to go over here with the acetate. And it turns out K has a +1 charge, acetate is a -1 charge, so no subscripts needed there. And then calcium is going to go with phosphate. Calcium is +2, phosphate's -3, so it's going to be Ca3PO42, and I put parentheses around it. So I figured out who my pairings are, and I used charges to determine the subscripts. Next steps, I'm going to use coefficients to balance the number of atoms. Notice how in steps 1 and 2 I didn't worry about how many calciums or potassiums there were. I just figured out what I'm making, and then now I'm going to balance. So over here, it looks like I have 3 calciums, so let's try putting a 3 over here. That gives me 3 calciums. It also gives me 3 times 2, 6 acetates, so I'm going to put a 6 right here. And then if I need 6 potassiums over here, I need to put a 2 in front. So now I've got 2 times 3, 6 potassiums, 2 phosphates, so I am all balanced. So step 3 is done. Then I'm going to ionize as needed to determine the net ionic equation. And what ionizes are aqueous ionic compounds and aqueous strong acids. So I have we got lots of stuff happening here. So I got 3 calcium ions. I've got 6 acetate ions over here. I've got 6 potassium ions, 2 phosphate ions. So that's what is in my reactants. And over here, I've got another aqueous ionic compound. I just realized I skipped a step. I should have figured out my states of matter. So this is an alkali metal compound. So this is AQ. Calcium phosphate is not on my list of things that are soluble, so I'm going to assume that it's insoluble. So my alkali metal compound is going to dissociate, so make 6 potassium ions, 6 acetate ions. And then my solid is going to stay stuck together. So I'm going to look for spectators. Looks like my potassiums and my acetates are the spectators. And my net ionic equation is 3 calcium ions combined with 2 phosphate ions to form calcium phosphate. So this is my net ionic equation for this precipitation reaction. So let's go through and do another one. I've got a solution of a strong acid and I've got sodium bicarbonate combining. So HCl right here, strong acid, and it looks like they give me the chemical equations already, so that's easy. So my next step is I'm going to use my pattern to figure out who the new pairings are. So my sodium and my hydrogen are going to switch places. So sodium combines with chlorine and hydrogen combines with HCO3. I'm going to look at charges to figure out the subscripts. So sodium's +1, chlorine's -1, so no subscripts there. Hydrogen's +1, bicarbonate's -1, so no subscripts there. And then you might say, oh, HCO3, well, let's just write that as H2CO3. And then you want to recognize, hey, wait, this thing, when I form H2CO3, I know that actually turns into liquid water and carbon dioxide gas. So that's really what I'm making. And then states of matter, sodium chloride, it's an alkali metal compound, so it's going to be aqueous. And I am balanced. I don't need coefficients. Everything's balanced already. I've got 2 H's, 2 H's, 1 sodium, so that's all good. So now I'm going to ionize my aqueous ionic compounds and strong acids. So HCl is a strong acid, so it's going to ionize. And how do I know that? Well, it tells me right here in the problem. And sodium bicarbonate, it's an aqueous ionic compound, so it's going to ionize. Remember, we can recognize our ionic compounds because they have a metal and some nonmetals in it, at least one nonmetal. And my sodium chloride is going to ionize. And then H2O is not an aqueous ionic compound or a strong acid, so it is not going to ionize. And same thing with CO2. Then you're going to look for spectators are sodium and chloride. So my net ionic equation is H plus, HCO3 minus, makes H2O and CO2. Alright, let's do one more here. So we've got potassium hydroxide and nitric acid. Potassium hydroxide is KOH. K is +1, hydroxide is -1, so no subscripts needed. Nitric acid is HNO3. It tells us it's a solution, that's why I'm putting AQ by them. I'm going to do my pattern. I'm going to have my cation switch places. So the H is going to trade places with the K. So HOH and then KNO3. I'm going to look at charge. H is +1 charge. OH is -1, so no subscripts needed there. K is +1. NO3 is -1, so no subscripts there. And I might also say, hey, HOH, that is actually H2O. That's water. So filling in states of matter, you want to recognize that water is going to be a liquid. And then this is a nitrate, and so we know nitrates are always soluble, so that's going to be aqueous. So then we're going to ionize them. So let's assume, I didn't really say that nitric acid was strong, but we're just going to mainly deal with strong acids right now. So let's assume it's strong. And if you're not sure on a test or quiz, just ask me. But this is an ionic compound. It's going to ionize into K plus and OH minus. My strong acid is going to ionize into H plus and NO3 minus. Water sticks together, does not ionize as a liquid. And then this over here, my K plus and my NO3 minus are going to ionize. So my spectator is going to be K and NO3. So what's left over is OH minus and H plus, making H2O. And you will find that if you have a strong acid and strong base reaction, you're always going to have the same net ionic equation, no matter what your acid and base are.